let's say we're trying to find the derivative of cos x. One way we can go about this is to use our limit expression for a derivative. So we're going to replace f of x here with cos x, the thing that we're trying to differentiate. We're going to get the limit as h approaches 0 of cos x plus h minus cos x all over h. From here, we're going to need to simplify this down to figure out what the derivative of cos x is. So what we can do is use a trigonometric identity on cos x plus h. So this will be equal to, still the limit as h approaches 0, of, we're going to do cos x cos h minus sine x sine h minus cos x. That's just from here. All over h. All right, now we're going to do a little bit of reordering. I'm going to put this cos x at the back in front of this middle term here. And then I'm going to factor out a cos x from these two terms. So we're going to have the limit as h approaches 0 of cos. And when we factor out the cos x from this term, we're going to just be left with the cos h. And when we factor out a cos x from this term, it'll just be minus 1. Minus sine x sine h. We can double check because if we're going to distribute this cos x here, we're going to get the cos x cos h. And if we distribute it to the negative 1, we're going to get the minus cos x. So we didn't really change anything, just reordered it. Still over h though. From here, we're going to break apart the limit into two different limits, and they'll both have h approaching 0. One is going to be this here, and the other is going to be this here. And they're going to be subtracted because we have that subtraction right there. So the limit as h approaches 0 of the first one, cos x cos h minus 1 all over h, minus the limit as h approaches 0 of sine x sine h, almost forgot that one, also over h. And if we're going to subtract these two fractions together, you'll see we get what we started with here. So we just broke that apart. From here, we have a factor, cos x, without the variable that we're taking the limit of, without an h. So we're able to pull that out to the front. And same thing here, sine x doesn't have an h in it, it's a factor of the numerator, so we can pull that out in front of the limit. So I'm going to rewrite it like that. We have cos x times the limit as h approaches 0 of cos h minus 1 over h minus sine x times the limit as h approaches 0 of sine h over h. All right. Here we have two fundamental trigonometric limits. This one over here is going to evaluate to 0. If you want to check that, you can plug in values of h close to 0, and you should get a number close to 0 as your output. This one's going to be 1. And I do have videos on both of these if you want to check that out. If this limit right here evaluates to 0, 0 times cos x is just going to be 0. We don't have to worry about that. If this is 1, this whole chunk here, 1 times negative sine x will just give us negative sine x. And that is going to be our derivative of cos x.